Holy crow, folks. We've got geomagnetic storm conditions. We've got new sunspots formed in the southern hemisphere and lots more to cover today on the Smash News Network, least busted name in news. So let's blast through the daily space weather. This is composite imagery from the SDO. Massive coronal holes just moving past the Earth-facing zone. Great view of the North Pole coronal hole. Is the sun going to kill us all? Let us know in the comments what you think. Here's our colorized magnetogram, and the new sunspot is this area right here. Right there. Right there. That'll be sunspot 3078, I think. So some more activity kicking up here. You'll see that sunspot form on this intensitygram image as well. The place to really watch is this area down here in the southwest. Likelihood of large flares from that region is very high. Let's take a look at volcanoes as Fagradosville continues to erupt. Some spectacular imagery all over the internet of Fagradosville. The new rift that's opened. You'll see it all over social media and so on. A curtain of fire accompanied with a new forming lava flow field from that current eruption. Here's some imagery from that. Spectacular drone imagery there. Nighttime in Iceland. Excellent. Yet another reason to follow us on Twitter, because we shared a different video. Karimsky also erupting. That's an uptick there on the Kamchatka Peninsula. Karimsky producing a 25,000-foot ash plume, flight level 250. Shivaluch, flight level 150, as it also explodes. So two exploding volcanoes there on the Kamchatka Peninsula as well. Sakurajima down on Kyushu, Japan, flight level 080. It's an 8,000-foot ash plume, 6,000-foot ash plume from Subanose-jima. And moving down to Indonesia, we've got Krakatau remaining on the list here. Flight level 080 from Krakatau. 8,000-foot volcanic ash plume. 14,000-foot volcanic ash plume from Semeru on the Isle of East Java, Indonesia. Semeru exploding. Headed down to South America, we see Nevado del Ruiz exploding. In Colombia, flight level 230. In Ecuador, flight level 210 as Sangay explodes. Sabancaya also exploding, flight level 220. It's a 22,000-foot ash plume. And please don't pole vault the caldera. Another thing you may see if you view us on social media is this latest imagery of Betelgeuse. Yes, check out that imagery. The latest high-res image in infrared from the James Webb Space Telescope. Oh my God, look at the detail of Betelgeuse. What an incredible plasma cloud surrounding the red supergiant star. Twitter.com/smashomash. Again, we did share another series of images from the Fagradosville eruption. You'll have to, once again, visit our Twitter page to view that. Next, looking at earthquakes here briefly. Largest quake of the past 24 was a 5.8. North of Japan, south of the Kamchatka Peninsula. That one came in at 1340 yesterday afternoon. That's 1340 Universal Time. So quite a few quakes there around the Pacific Rim. Nothing higher than a 5.8 magnitude. We're just going to scroll up the list here. If we missed anything noteworthy, please let us know in the comments. Papua New Guinea had one of the largest quakes also. That was a 5.6. That came in at 5:37 this morning. South Sandwich Islands had a 5.0. That was at 7:18 this morning. And let's move on to remind our viewers to follow us on Twitch. Twitch.tv/smashomash. We regularly stream live, and thanks for leaving a comment. Good morning to you too as well. Tinman1057 and Consumer Tip. Make sure you plug in your coffee maker if you would like to brew coffee. They work way better when they're plugged in. So thanks to our YouTube subscribers. If you're new to the channel, please press like, subscribe, share, leave a comment. Tell us how long you've been watching the content. Tell us how you found the channel. Once again, congratulations on realizing that it exists. Today's featured product is Do Not Pole Vault the Caldera. Our finest days lie ahead, folks. I know it may seem like doom. I know you may see a lot of doom and nonsense on YouTube, as fear-mongering is, for some reason, the name of the game. So, I know there are a lot of negative and ridiculous stories on YouTube. Trust me when I say, or don't trust me, I don't really care. Our finest days lie ahead. I'm just going to say it. You can believe me or not believe me. It's perfectly fine. Remember, folks, we're putting out this content at massive personal risk and responsibility. Give Smash staff a raise by picking up some merch with the great design Do Not Pole Vault the Caldera. It also features the YouTube channel and our homepage, smashomash.com. More on that momentarily. If you want to support the channel via subscription services, do so via the Smash Team site, smashomash.com/smashteam. Join at the gold or silver level. Send us a few bucks per month. Help ensure that these videos will continue to exist, remain publicly visible, and free for all to view. You can find links to our social media there on the Smash Team page as well. Once again, the URL is smashomash.com/smashteam. You'll also find links to our SureMed site. If you want to beef up your health coverage, this is not insurance. This is just an association membership. And I'll tell you right now, the teledoc service, Doctors by Phone, is worth in itself $20 per month. You'll also get virtual veterinarians, dental discounts by Aetna Dental Access, vision discounts by Coast to Coast Vision, and more by becoming just the base member. If you join at the premier level, you'll also get accident and critical illness insurance. That's only $35 a month. Once again, links on the homepage. You'll find it right at the top right there at smashomash.com. Welcome to the Neo-Renaissance. And once again, congratulations on realizing the content exists. Since we make just this side of nothing to put the videos on YouTube, please support us in whatever way you shall, whether that's with a like, a subscribe, etc. We appreciate your simply viewing the content. And once again, congratulations on realizing that it exists. So that right there, that is the place to watch for major flares. We've got 3 significant sunspot groups setting, and those who are regular inhabitants of our channel will remember that large flares are much more likely at the limb because of the likely anisotropic nature of X-ray emissions from the closest star. It's giving us insight into perhaps what stars are made of. So we've got a new sunspot forming right in this area right here. That'll be sunspot 3078, I believe, as long as this one up here in the northeast is named. And here's our ionized helium wavelength, 304 angstroms from the SDO. And let us know in the comments what your favorite telescope is. Here at the Smash News Network, I think our favorite telescope is indeed the SDO. Whew. Let's continue on. Since there's a geomagnetic storm happening, we'll get to it in a moment. The radio flux is at 116 solar flux units. There's the 1-year graph of that. It's that black line. That's the 10.7 centimeter radio flux. You can see how proportional that is to sunspot number. Practically every peak and every trough is associated with a similar peak and trough in sunspot number. So here's our Space Weather Enthusiast dashboard. We've got a significantly elevated solar wind here. It showed up rather unexpectedly and created a G2 level geomagnetic storm with a KP6 right around first thing this morning. And yeah, geomagnetic storm can actually late last night Universal Time. The KP6 occurred, and we're still in geomagnetic storm conditions. It was caused by a high-speed solar wind pulse. We'll get to that data in a moment. First, the last 4 hours of Earth's magnetic moment from space. Space, a frontier. This is what Earth's magnetic moment looks like from it, most likely. It's the space weather modeling framework. Again, the last 4 hours, the scale you're seeing here is magnetohydrodynamic pressure. nanopascals. We'll also show ground magnetic perturbations. Those dark red areas are the most likely places to see aurorae. Keep in mind it's showing the time and date stamps as well. Ground magnetic perturbations also show the last 4 hours. The scale here is nanotesla, magnetic flux density, Earth's magnetic moment from the ground. Once again, Earth remains in geomagnetic storm conditions, KP5. And here's the auroral forecast, showing you the likelihood of aurorae. If you see red, you're like 80+% likely to see aurorae in those areas. And of course, Antarctica, only a few people live in Antarctica over the wintertime. Northern Hemisphere, we expect to see lots of auroral imagery. We'll retweet on the Twitter page. So there's your KP index over the last 3 days. Again, we reached KP6, a G2 geomagnetic storm, rather unexpectedly, and we remain in geomagnetic storm conditions at KP5. Moving to the real-time solar wind, we saw the solar wind speed get all the way up to over 650 kilometers per second, just for a brief period here. Current conditions are about 556 kilometers per second. Solar wind density here a little elevated as well, 12.84 protons per cubic centimeter. High-speed coronal hole wind stream causing that geomagnetic storm. It's also caused all kinds of sawtooth patterns there showing up in the GOES magnetometer readings. High-speed plasma, it affects the magnetometers. And also we saw pretty strong fields here, but not a real solid negative BZ component. So the fields were all the way up as high as about 14 nanotesla. And there is the GOES magnetometer. That is measured from a geosynchronous near equatorial orbit by the GOES 16 and GOES 17. Next, we've got your top view ecliptic plane field plot. Earth remains in a North Pole current sheet shown there in green. Here's our line of sight plot. And next we'll show coronal holes, and we've got some great close-ups of these well-defined coronal holes. They are North Pole oriented. And just a quick reminder that the North Solar Polar Field is still largely oriented at the North Heliographic Pole, which means it's not really anywhere, it's barely into its migration yet. We've got a lot more of solar cycle 25 to come. So you can see a very polar-oriented coronal hole up here. That is the North Pole solar polar field area. And solar cycle 25 has barely just begun, folks. Lots years yet until we expect solar maximum. We also brought up, that's 193 angstroms. We also brought up 211 angstroms. We're going to show a close-up as well, since it shows the southwestern limb and those two well-defined coronal holes right around the equator. Great imagery there, once again, from SDO. Next, we'll move into sunspots. What evil lurks in the hearts of coronal holes? Streams of high-speed protons, that's what evil. So here's the new sunspot forming down here. That should be known as 3077. There's one up here that should be known as 3076. As these three groups set here, they're likely to produce major flares. Let's get some close-ups. So here's our 24-hour intense continuum imagery from SDO. Let's go from least to most exciting. So again, we do have a new group forming. This will be known as 3078, I believe. It's already beta gamma class. The areas in the northeast are a little bit more interesting. These are more magnetically complex, especially this one in the middle here. That's 3076. This one up here will be 3077. The two latter that we've named here, those are both beta gamma class sunspot groups, but this is the most interesting place of all. This is the most likely spot to see major flares. Don't be surprised to see an M or even an X class flare coming from this area. There is a lot of magnetic complexity going on down there in the southwest. So as far as X-ray output, the sun's been underperforming despite that many sunspots. Don't be surprised to see some radio blackouts today with a large flare or two. Great wavelength to view flares is 94 angstroms. It takes 10 images per minute instead of only 2. And we're going to show another close-up of that southwesterly region right after we pause for a station identification. Thanks for tuning in to the Smash News Network Least Busted Name in News, where we cite facts, which is probably why we are only at about 2,500 subscribers. Whew. Here's that close-up we talked about. We put up a bunch of clips yesterday. We'll put a bunch of clips up today as well. Since the channel features the most detailed space weather in the world and the most spectacular imagery of the sun you'll find anywhere on the entire internet, we figure we might as well add some value-added services. Smashobash.com. No spikes in the proton flux. If we see a major flare, we might see spikes in the proton flux and polar radial blackouts, but at the moment, no such thing going on. We invite our viewers to look up. If you do so before dawn, you may see a planetary pileup. Saturn, Jupiter, Mars, and Venus all rising ahead of the sun once again. Here's your solar system forecast for the next week. We've got a gibbous waxing moon as full moon approaches in about 3 days. Here's the 1-week forecast. There's where things will be on August 15th. Mercury coming back around to the more populated side of the solar system. We've got a full day of coronagraph imagery from George Mason University. This is yesterday, August 7th. And we'll also show some coronagraphs from Stereo A and the Soho-Lasco C3. Stereo A on your left, Soho-Lasco C3 on your right. And the only coronal mass ejections we've seen were on the far side of the sun. None earthly directed on the available imagery. Don't be surprised to see additional coronal mass ejections, though. We've got a lot of filaments, and we're going to cover them in just a moment. And here you go. This is the hydrogen alpha imagery from El Teide, Spain. And you see all those dark areas. Those are all filaments. Some prominences in the north as well. They're the same feature, though, folks. And these filaments could be headed your way any moment. Remember, folks, we don't need solar flares or sunspots to see coronal mass ejections. In fact, one down here clearly looks like it's ejected right there. That filament, it was there, and now it's gone. Here's the last about 2.5 hours in ionized helium from the GOES 16 SUVI. And here's the last 24 hours in the house favorite wavelength 171 angstroms. Which means it's time to chew bubblegum and do bonus features. And we're all out of bubblegum. So let's do it. Our bonus features begin with charging hazards. We've got some significant charging hazards here, especially over the Pacific Ocean. Also over the Caribbean, some significant surface charging hazards there caused by low-energy electrons building up on the outside of spacecraft, satellites, and some more minor charging hazards over the Central Pacific, moving into the Western Pacific. That's your satellite's community dashboard. Goes electron flux here kind of low, as we typically see with high-speed coronal hole wind streams. Here's the relativistic electron forecast model. And I would say these are going to be a little bit lower here, as we can expect a few days, actually, of coronal hole high-speed stream activity. Here's the one-year chart to put the relativistic electrons in context for you. Again, we're at rather low levels here. And let's take a look at the F ionosphere layer, located at about 300 kilometers of altitude. So this is the F layer of the ionosphere in vibrational frequency, millions of vibrations per second, aka megahertz. And we show the anomalygram daily as well to help put this one in context. It's the bridge between Earth and space. This is the anomaly in megahertz from the 30-day median. Significant low-frequency anomalies there, and rapid swings from low to high-frequency anomaly there around the North Polar region. So quite a bit of shaking going on at the bridge between Earth and space during this period of geomagnetic storm. There's the latest image. That's 1015 universal time ionogram, 1015 universal time anomalygram. We'll also show the total electron content forecast, which is the area between your GPS satellite and your handset. In that area, you've got multiple different regions. You've got the plasmasphere, which is just below the satellite. You've got the inner Van Allen belt, which is especially dense around the equator at noontime. You've got the inner plasmasphere, and below that you've got the ionosphere. The free electrons in that entire area represent the total electron content forecast, the CTIPE, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And we do have some electrons a little bit out of their normal location here. You're going to see some high electron contents quite far from the equator there, especially in the southern Indian Ocean, the southern ocean around Antarctica. When your GPS must communicate through a lot of free electrons, it causes signal refraction, and you can see errors of thousands of miles. We've even demonstrated it here in North America. I've done bike rides where my GPS thought I had an average speed of 10,000 miles per hour. Let's get back to the sun. Here's the latest intensitygram and the latest colorized magnetogram. We've got this new sunspot down here. It's actually weakened a little bit since we did show prep. Again, don't forget to keep your eye on the southwestern limb. It's where we can expect to see solar flares. Let's bring up some more composite imagery here. This is yesterday and today in ionized iron. 94, 335, and 193 angstroms. That is where we will have to close out the space weather content, but don't go anywhere, as we've got meteorology content as well. Let's do it. And we're going to start out with a special presentation today. This is the nullschool.net space portion. Yes, space, a frontier. It's one of the choices you can pick for the mode of data display there on nullschool.net. It's showing you the most likely places for aurorae. Aurorae a little stronger in the southern hemisphere. We sort of doubt you'll even be able to see any from southern New Zealand. But that's about what the current auroral situation looks like. Let's get to our regularly scheduled meteorology segment. These are the surface, like sands through the hourglass of time. These are the surface winds of the eastern world. These are the jet streams, the 250 hectopascal winds. Jet stream quite chaotic here north of the equator. Some cold temperatures likely rolling in there to southwestern Australia. Here are the jet streams of the Americas. And here are the surface winds of the western world. And here are the surface winds of the central world. Shout out to our viewers from all around the planet. Greetings, Earthlings, as well as the rest of you. Congratulations on realizing the channel exists. Those are the jet streams of Europe, Africa, and the Middle East. And let's move on to our weather.gov map. Yeah, weather.gov. If your county's lit, click your county. Additional flooding expected here, including some flash flood warnings for southern Wisconsin. If your county's lit, head to weather.gov, click your county. Gale warnings there around Hawaii. And excessive heat for the Northeast. Here's our total accumulated precipitation forecast based on the GFS model. Some heavy rains coming to Louisiana. Looks like as much as 3+ inches there. Again, that's your GFS total accumulated precipitation forecast. Precipitation amounts shown here in inches. Here is our GFS pressure and precipitation forecast. Again, that's the next 72 hours. We show 72-hour forecasts because they tend to be accurate, not alarmist. Facts, not nonsensical propaganda, are what we show on the channel. Next, your pressure maps from windy.com. Low pressure dominating the northern Atlantic here. The area around Greenland. Very low pressure environment. High pressure environment in the northern Pacific. And a high pressure environment here in between the Azores and Ireland. Continuing on, it's our NASA GOES Lightning Mapper to show you where the major storms have been for the past about 10 hours. You can see those heavy storms there in northern Illinois and southern Wisconsin. And let's check out a real-time lightning map right after we pause once again for station identification. Welcome to the Smash News Network, least busted name in news. Here's our real-time lightning map. And I think we have some terrestrial strikes once again in the U.S. Northern Illinois. Lots of lightning showing up there in quite a concentrated cell. 3 rather concentrated cells. It's going to be a stormy day on Lake Michigan. Continuing on, here's our U.S. Doppler radar map. Quite a bit of precipitation there, especially in the southern portion of Alaska. Let's focus on the lower 48. Here's your shortwave radiation map showing clouds and fog. We've got some moisture here headed toward the southeastern U.S., straight from the Atlantic Ocean, as we've got some jet stream inversion happening here. Some of the jet stream here blowing backwards. Saharan dust in this area, most likely causing all that dryness. Tamping down convection is all that dust. There's your water vapor map. That should help clarify things. Let's do a recap. It's the U.S. Doppler radar. Heavy storms here, just making their way onto Lake Michigan. There are going to be some high seas on Lake Michigan today. There is clouds and fog. And there is water vapor. Hopefully that clears things up. Hopefully you're keeping your eye to the sky. Hopefully you're not viewing too much nonsense on YouTube. And once again, thanks for tuning in, folks. May that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.